Dear students, under the series of lectures on the topic sequencing problems, here we have type 2. Previously, we have learned problems under type 1. Now, here the type 2 is n jobs on 3 machines. So, let us learn the first problem under this topic. Find the sequence that minimizes the total time required to complete the following tasks, which go through the machines M1, M2, M3 in the order M1, M2, M3. Also, determine the total elapsed time and the idle time of the machines. So, there are jobs given here, and we have three machines. Previously, we dealt with two machine problem. Now, we are going to learn how to solve a three machine problem. Now, if you see here, there are seven jobs and we have three machines. So, this is a seven job and three machine problem. First step is we have to test whether it is possible to convert this seven job three machine problem into a seven job two machine problem. Using that 7 job 2 machine problem, we can find the job sequence, and after finding the sequence in which the jobs has to be performed, we can find the total elapsed time and the ideal time as usual by considering all the three machines. You will understand it better when we solve this problem. So the first step is we have to test whether it is possible to convert this 7 job 3 machine problem into a 7 job 2 machine problem. And how to test it? We have two conditions. Any one of the conditions should be satisfied for that. So what are the two conditions? Let us learn now. The two conditions are, first condition is minimum of m1 should be greater than or equal to maximum of m2. If this condition is not satisfied, then either the next condition has to be satisfied. That is, minimum of m3 should be greater than or equal to maximum of m2. So if any one of these two conditions is satisfied, then we can convert this problem into a two machine problem and we can easily find the job sequence. So let us test these two conditions first. The first condition is, for that first we shall find what is minimum of m1. So minimum of m1, out of all the processing times, what is the minimum value that we have to find? We observe that 3 is the minimum. So let us write that. In a similar manner, let us find minimum of M3, because in the formula we have minimum of M1, minimum of M3. So what is the minimum value of M3 out of all these processing times in M3? We see that it is 5. So that we have to write. And then we have to find the maximum of M2. So maximum of M2, and that is equal to, out of all these values, which one is the maximum? So we see that 5 is the maximum. So let us write that 5 here. So now we shall test the first condition. First condition is we have to check whether minimum of m1 is greater or equal to maximum of m2. Minimum of m1 is 3. It is not greater than 5 and it is not equal to 5 also. The first condition is not satisfied for this problem. If this is not satisfied, we should check whether the second condition is satisfied. That is, minimum of m3 is 5 and maximum of m2 is 5. They both are equal. The condition is it should be either greater or equal. So this condition is satisfied. Therefore, we can convert this problem into a two machine problem and we can proceed to find the job sequence. So now let us see how to convert this problem as a two machine problem. In order to do that, we have to introduce two machines, new machines, that is m, n. So that is, the three machines will be converted to two machines. The first machine will be m. So I am representing it as m, and here we can represent it as the next machine as n. And how is this machine m we obtain? We obtain by adding the processing times of m1 and m2, and we form the processing time of the machine m. And the processing time for machine n will be m2 plus m3. So by doing this, we are going to find the two new machines M and N, and using that we will be finding the job sequence. So let us find the two machines M and N now. That is the processing times of M and N. So we have to form a table like this, where we know that M is obtained by M1 plus M2, just now we saw, and N is obtained by M2 plus M3. So let us do this now, this and this. For that, first we shall consider the processing times that is given. So given in the question. So these are the processing times given in the question. Now in order to find the processing time for M, we have to add these two, because this is M1, this is M2. Okay, M1 and M2. These values we should add and we should write correspondingly. So the first value will be 3 plus 4, which will be 7. So that we have to write. And then it is 8 plus 3, that will be 11. In a similar way, 7 plus 2, so it is 9, and 4 plus 5, again 9, and for E it is 9 plus 1, so 10, and then 8 plus 4, so 12, and then 7 plus 3, which will be 10. So now this we obtained by M1 plus M2. In a similar manner, by doing M2 plus M3, we will be obtaining this row. So these two we have to add. So 4 plus 6, which is 10, here 10, and then 3 plus 7, so that is also 10, and then we have 2 plus 5, so 7, and then 5 plus 11 is 16, 1 plus 5, so 6. So 4 plus 6 will be 10, and then 3 plus 12 will be 15. So we have obtained the new processing times. And this new table will be used only to find the job sequence and not the total elapsed time. So remember that. So in order to find the job sequence, we have formed this new table. Now it is a two machine problem. Now easily you know how to find the job sequence, as we have seen in our previous type 1. The same method we have to do now. So now I have drawn 7 boxes, so 7 blocks, in order to find the job sequence, as we have 7 jobs over here. So now we have to check out what is the least element of all these processing times. So if we check, the least element of all this will be 6. And the 6 it is not repeated, only once it has come. So 6 is in mission N. So that is actually this is N, and this is M. This is mission M, because that is the first mission, and this is N. Okay, it's not M1 and M2, it is M and N. So now M we have to write this way, and N we have to write this way. So if you see, what is this least value? It is 6. It is under mission N, so it has to be written here. And what is the corresponding job? It is E. So E we have to write here. And after writing that, let's give it a strike, since we have completed it. And next we have to find for the next least value. So if we check, the next least value is 7. 7 is repeated here also. So it has appeared twice, but since it has appeared in 2 different missions, there is no tie with it. We can easily sort it out. That is, this 7 has appeared in mission M, and the corresponding job is A. So it has to be written here. And this 7 has appeared in mission N, and the corresponding job is C. So it has to be written here. And after writing, let's just give it a strike. These two are completed. Out of the remaining, so we have 11, 10, 9, 16, 12, 10, 10, 15. So these are the remaining values. The least is this 9. And this is under mission M, and the corresponding job is D. So D has to be written over here under mission M. So this has to be, this is done. Out of the remaining values, that is the remaining processing times, we see that the minimum value is 10, and it has appeared 3 times. So it's repeated. And we see that this 10 has appeared in mission M, and these two 10 has appeared in mission N. So So this can be easily sorted out, that is G is under M. So here we can easily write it and we can just give it a strike. But since these two tens have appeared in the same mission, they have a tie between them. So in that case, what we have to do, for this 10 the corresponding value is 11, and for this 10 the corresponding value is 12. Out of these two, which is minimum? 11 is minimum. So this 10 has to be considered first. It is under mission N and the job is B, and so we have to write B over here, and then we have to write F over here. So these two jobs are also done now. So therefore this is the job sequence. We now have to perform these jobs under the machine M1, M2 and M3. So the new tabular column will be so we have jobs here, machine 1, same time in, processing time and timeout, and similarly machine 2, machine 3, time in, processing time, timeout, and similarly for this. So we have to write this. Usually we do for 2 machine, but since the problem is for 3 machine, we have to do for all the 3 machine. And remember, we converted it into a 2 machine problem only to find the job sequence. But while performing this tabular column, that is to find the total elapsed time, we have to consider all the 3 machines. And let me fill this job by the sequence that we have found. So I have taken and I have written the job sequence that we have found in the same order. Now we shall fill in the processing time of machine 1, machine 2 and machine 3 that we have in the question. So these are the processing times. So these 3 we have to take and fill it here. So here we have to fill the processing time for machine 1 for these jobs. So that is very important. And to avoid confusions, I have drawn the horizontal lines also. So first, if you see, we have job A, and what is the processing time under machine A? It is, machine 1, it is 3. So let us take and write that over here. And for job D, it is 4. Job G, here we have 7. For F, it is 8. For B, it is 8 again. For C, it is 7. And for E, it is 9. In a similar manner, we have to do for machine 2. So machine 2, the processing times are here. First is A. So for A, it is 4. And then D. For D, it is 5. For G, it is 3. For F, it is 4. For B, it is 8. Here for B it is 3. So this is 3. And then for C it is 2. And for E it is 1. So while taking and writing, do it very carefully. Now for machine 3 we have to do. For job A it is 6. Yeah, we have to write 6 here. And then D, it is 11. And then we have G, 12 it is. And then we have F, so it is 6. And then for B, it is 7. For C, it is 5. And then for E, it is 5. So now we shall start with the problem. So first, initially A will have the time in as 0, and then time out will be, it is being processed for 3 hours. So 0 plus 3, it will be 3 here. Then this 3 we have to write here, and then 3 plus 4, which is 7. So 7 has to come here. 7 plus 7 will be 14, and then 14 will be coming here. 14 plus 8, so that is 22. So that's 22 we have to write here. 22 plus 8, so that will be 30. And then the 30 we have to write here. So 30 plus 7 is 37. So 37 we have to write here. And 37 plus 9 is 46. So we are done with machine 1. Time in and time out is done. Now for machine 2, what is the time out for machine A? 3. So that should come as usual. So 3 should be written here. So 3 plus 4 is 7. Now we have to check this timeout and this timeout whether 7 is greater or this value. Both are same, so we have to write 7 here. So 7 plus 5. So that will be 12. Now we have to check whether 12 is greater or 14 is greater. Which is greater out of these two? 14 is the highest. So that we have to write. So 14 plus 3. So that will be 17. So now 17 is greater or 22. 22 is the greater value. So 22 should come here. 22 plus 4, that is 26. Now which is maximum? 26 or 30? 30 is the maximum. So 30 has to come here. So 30 plus 3 is 33. 33 is greater or 37? 37 is the greater value. So 37 plus 2. So that is 39. Now after this, 39 is greater or 46 is greater? We have to check. Obviously 46 is greater. That we have to write. Then 46 plus 1 is 47. So therefore time in and time out for mission 2 is done. In a similar manner we have to do for mission 3. So what is the time out for mission 2 in for job A in mission 2? It is 7. So that time we have to write here. So 7. And then it is being processed for 6 hours. So 7 plus 6, that will be 13. So we have to check whether 13 is greater or 12 is greater. Obviously 13 is greater. Then 13 plus 11 is 24. Now 24 or 17 we have to check. Obviously it's 24. So that we have to write here. Then 24 plus 12 is 36. Now which is greater, 36 or 26? Obviously 36, so that you have to write here. And then 36 plus 6, that is 42. Now we have to check 42 or 33. So 42 is greater. 42 plus 7, which is 49. 49 is greater or 39 is greater? 49 is greater. So that we have to write here. 49 plus 5. So which is 54. 54 is greater or 47? Obviously 54 is greater. So that we have to write here. So 54 plus 5 is 59. And this gives us the total elapsed time. So therefore 59 is the total elapsed time. So let us take and write it. So therefore the total elapsed time is equal to 59 hours. The question is also about the ideal time. So I have included that hours here. Please make a note of it. So we have to also find the ideal time of both the machines. All the three machines. So let us do that. For that we need the total of the processing time for all the three machines. That is, we need this total processing time. As you all know, we wrote the processing time here. Processing time of machine 1, machine 2 and machine 3. We have to sum up all these values. And if we sum up, what we get is 46 for this. And for this it is 22. So kindly you can check it by doing. And for this we get 52. So add all these values and check. Similarly, all these values if you add, you are getting 22 and 52 over here. Now we have to find the ideal time for each machine. So the ideal time for machine 1 is total elapsed time minus the processing time for machine 1. What is the total elapsed time? It is 59. Minus what is the processing time for machine 1? Total processing time is 46. So we have to subtract it, and therefore that is equal to 13 hours. So this is the ideal time for machine 1. In a similar way, we have to find the ideal time for machine 2. So ideal time for machine 2 is total elapsed time minus total processing time of machine 2. And that is equal to, this is 59 total elapsed time minus the processing time. We have taken the total here. So that is 22. So that's equal to 37 is the answer. So 37 hours is the ideal time for machine 2. And finally we have the ideal time for machine 3. So ideal time for machine 3 is equal to total elapsed time minus total processing time of machine 3. Total elapsed time is 59 minus the total processing time is 52. So we have to subtract this and we get 7 hours. So therefore this is the ideal time of machine 3. So therefore, this is the method how we have to find the total elapsed time and the ideal time for a three machine problem. And very importantly, you must remember to convert this three machine problem into a two machine problem. And after that, you have to find the job sequence. And after finding the job sequence, we have to find this total elapsed time and the ideal time for all the three machines. So kindly follow the upcoming video lectures for more problems under this topic. Thank you.